Okay, students, welcome to Chapter 10, Exponential Functions, Expressions, and Equations. Well, we'll start with 10.1, Exponential Functions. So we're going to expand on what we've done in Chapter 7 here, skipping all the way to Chapter 10. So let's see. So first we'll start with the definition. A quantity q is an exponential function of t if it can be written as q equals f of t times f of t equals a times b to the t. A and b are constants, and b needs to be positive. That's very, very important. We always want the base of the exponent to be positive because we don't want to take a negative to varying powers, which can cause problems. All right, so a couple things to note. We call a the initial value, so that means f of 0 always gives us a. And b we're going to call the growth factor. Now there are two types of things we can have here for b. Since we want b to be positive, first we can have b between 0 and 1. Well, if b is between 0 and 1, then we have exponential decay. So the graph will look like this. The domain is all real numbers and the range is 0 to infinity. So here we have exponential decay. So also there's a horizontal asymptote at the horizontal axis here, at the t-axis. All right, the other option is b bigger than 1. If b is bigger than 1, then we have exponential growth. All right, so we're growing as time passes. The domain, again, is all real numbers, and the range is also 0 to infinity. All right, and notice we always cross at A on the vertical axis here. Okay, so now that we have that, let's go through some examples. So big 2, little a, are the functions exponential? Well, so the first function we're given is q equals 12 times t to the fourth. Well, what do y'all think? Is this exponential? So the answer here is going to be no. All right, this is not exponential. This is a power function. Recall that an exponential function, right here, the variable is the exponent. A and b are numbers. The variable is in the exponent for an exponential function. Okay, what about the next one? How about number 4? Q equals 0.2 times 3 raised to the 0.75t. Well, as it's written, it's not. All right, so we have to make some adjustments. We do have a variable in the exponent, but what we want to do is we want to make a quick adjustment. This is going to be 0.2, 3 to the 0.75 to the t. So here, now it's written as an exponential. So q is exponential. The initial value is going to be 0.2. And the growth factor is 3 to the 0.75. Okay, moving on. All right, number 10 says, can this be described by an exponential? The quantity of a prescribed drug in the bloodstream if it shrinks by a factor of 0.915 every 4 hours. And the answer here is yes, because exponentials have, you're dealing with repeated multiplication. So we look for multiply words, and factor is a multiply word. So let's see, the quantity of a prescribed drug, so we can call that Q, is, let's see, the bloodstream, it shrinks by a factor of 0.915 every 4 hours. So we'll have some original amount, we'll call it q sub 0, times 0.915 every 4 hours. So if we let t be in hours, then what do you think the exponent's going to have to be? It's going to be, so if t is in hours, and we want every 4 hours, so this is going to be t divided by 4, because we want to multiply the factor by itself every 4 hours. So when t is 4, then this is 1, and I get the full thing. So then to finish, we'll have Q0 0.915 to the 1/4 to the t. So whatever this number is, you can plug that in your calculator, and that would give us the growth factor. Okay? How about this one? Little c. Write an expression representing the area covered by marsh if the marsh starts at R acres and decreases by a factor S 9 times in a row. Well, this one's relatively simple. Area, we start at R, so that's our initial value, so R, and then we decrease by a factor of S 9 times in a row, so S to the 9th. So, and that's it. That's all they want here. Okay, I know some of y'all are going to get fussy because the 9 is not a variable, but this is just an expression for some area. So if they give us a value for R, they give us a decay rate, we can figure this out for the area. All right, what about this one? Number 25. Let's sketch a graph of y equals 800 times 0.9 to the t. Well, we just go back to our original, our first page of notes. So here we look at our growth factor. It's 0.9, so that's between 0 and 1. So that means the graph will look like this. So we basically just draw this with a couple additions. So we'll have our axis. 800 is our initial, so we just make a mark at 800 right there. Doesn't have to be too high, but we're decreasing. So we have something like that. Just like that. So, and then this is y, and this is t, and that's it. That's really all we want, because they just want us to sketch a graph. It doesn't have to be overly detailed. Okay, how about another one? Little e. An investment grows by 1.2 times the first year, by 1.3 times the second year, then drops by a factor of 0.88 in the third year. By what overall factor does the value change over the 3-year period? Well, this one's actually kind of simple. Factor is simply going to be the product of those 3 factors. So 1.2, 1.3, and 0.88. 1.2 times 1.3 times 0.88. And if we take our calculator out, say 1.2, turn on 1. Let's clear that out. Times 1.3 times 0.88, and we get 1.3728. So this is the answer. This is the overall factor that the value changes over the 3-year period. Done. All right, how about this one? F. These last two are a little trickier. Write in the form Q equals A times B to the T. All right, so here, this is our A. That's not a problem, but this is going to be our problem. We don't want 3 to the T minus 2. We want something to the T. So we got to do a little bit of work. So this is going to be 45 times 3 to the T times 3 to the minus 2. Okay, remember, since this is, we're adding the exponents essentially here, or you can also say we're subtracting the exponents. So you can write it this way, 45, 3 to the t divided by 3 squared, since we're subtracting the exponents. In either case, I get this in the next line, 3 to the t divided by 3 squared. So that gives me 45 times 3 to the t over 9, which is 45 over 9 times 3 to the t, and 45 divided by 9 is 5. So that's 5 times 3 to the t. So our final answer here, I'm running out of space, Q equals 45 times, Q equals 5 times 3 to the t. That's our final answer here. Sorry, that was a little messy. All right, well, let's try another one. And this is the last one. So let's see, more work. So this is 100 to the t to the 1/2 divided by 5, change the square root to an exponent. Then it's power to a power, so this is 100 to the 1/2 t over 5. Well, then we can separate this product, so that's 100 to the 1/2 to the t over 5. continuing up here, 100 to the half is 10 to the t over 5, and now I can simply write this as 1/5 times 10 to the t. And that's our final answer. Hope you enjoy this. Have fun with your homework, and I'll see you guys tomorrow.